Okay, now we will find the flow table for maximal compactable pairs. So here we have found the closed covering, that is maximal compactable states. We have found A, C, and D, B, E, and F. So from that we will be seeing the flow table for maximal compactable pairs. Okay, so you know the primitive flow table. Okay, so primitive flow table, that primitive flow table you have to write as such. Okay, so for A, that's C and D, I suppose. Yeah, A, C, and D, you have to write as such. Likewise, B, E, and F, you have to write the table. Just copy the table from the primitive table, those rows alone, and then write as such. Okay, now we have written. Okay, and now you have to minimize this table. Okay, merging the flow table. Next, you have to merge the flow table. This merging is done by, see, you have to merge, like, let's take the row columns C, C, C. So everything, you don't have any conflicting. Obviously, you don't will not be having any conflict because they are maximal compactable. Okay, so dash 0 and 0, you have to take 0. Okay, A dash, you have to take A, and 0 dash dash, you have to take 0. Okay, likewise you have to take like this. Okay, so merging flow table, you have to take everything and then merge, and then you have to write. Now after merging, let's write, this is reducing flow table. Now we have reduced by the flow table by merging the flow table. Okay, now let's have A is equal to ACD. Let's minimize that. So ACD, let's take it as A, and BCE, sorry, BEF, you take it as a B. Just write, just substitute A with everybody, that is C and D, and then write the table here. Now we have this table. Okay, reduced table. After the reducing, you have some dash here. Yes, certain values you don't have a value, either you have a dash. Okay, so for those you have to fill in the values. Okay, you have to fill either 0 or 1 or don't care condition. You have some condition for filling here, that is, if you have either side 0, you have to say fill 0, so this will be a 0. And if you have either side 1, you have to fill a 1 here. If you have either side 1 and 0, you have to fill a don't care. That's what I have written in this red markings. Okay, just you can read and understand. Next, you have to write the transition table, this transition table for this two fields. So A, this for states like A, left side field will be one transition table, and the right side will be your outputs, so that you will have another transition table. So two transition tables you have to write. Here A and B, they have substituted by using 0 and 1. They substituted. After writing this, just write zeros and ones. Okay, and then write here zeros and ones, and then continue. Here this output will be as such 0 0 0 0, so everything zeros. 1 1 1 1, here write 1 1 1 1, and then complete. Okay, now you will have your input and your output. Okay, so you will have the diagram based on this. So y will be your output. Okay, and this y will be your feedback. Yes, so you'll have D and G. As I told, D is a data and G is a gate. Okay, so those inputs will be there from as per the question, and then you have to draw this diagram. So with this diagram, your analysis of your asynchronous circuit is over. This is your asynchronous circuits analysis. Okay, so you can see, you will have first, you will have your understanding. Okay, you'll just draw your diagram, then your state table, then your primitive flow table, then your implication table, continued by compactable pairs, and find the maximal compactability, merge it, and then draw a transition table from that and your diagram. Okay, so with this, your analysis of asynchronous circuits are over. Thank you so much.